problem number 1 on this homework is a heartbeat problem. It says Alexa's heart rate is 68 beats per minute. And it says if this is her average heart rate, how many times will her heart beat in 35 years? So the plan here, remember, we have to understand what's going on, how often her heart beats per minute, and then we're talking about over 35 years. So the plan would be to figure out how many beats per hour and move on to how many beats per day, and then move on to how many beats per year, and then we could figure out in 35 years. So that's the plan to move along that idea. So to figure out how many times her heart beats per minute, moving that to per hour, there are 60 minutes in 1 hour. So that means it's 60 times more often, right? So when you're trying to think about which direction to multiply, you think, well, it's got to beat more in an hour than it does in a minute. So I better multiply to make that a bigger number. So 68 times 60 equals 4,080 beats per hour, right? And it's good to include your units so that we can keep track of where we're at. Then take this times 24 to figure out for the day, right? So this times 24 is 97,920 beats per day. Then we're going to take this times 365 because there are 365 days in a year. So that's 35,740,800 beats per year. And then take this times 35 to figure out for 35 years. Now, my calculator returns that in scientific notation. I'm not sure if yours does or not, but my calculator returns something that looks like 1.25 e to the 9. Okay, and so E9 is what it says. What that means is 1.25 times 10 to the 9th. That's scientific notation. And if you remember, this times 10 to the 9th means sort of the same thing as move this decimal point 9 times. So if I move that decimal point 9 times, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got it, and this is a rounded number, obviously. So my heart would beat 1,235,000,000 times in 35 years. So that's actually pretty standard. So my heart has probably already beat that many times in my life right there. Now, if Alexa's heart beats this many times, how many days in decimal form would that have elapsed? So again, now we've got how many times it beat, and we're going to figure out how many days. So again, her heart beat that many times. We can from there figure out how many minutes that took for it to beat. So the first step in the plan is to find out for minutes. And then the next step would be hours. And the next step would be days, right? So to figure out how many times, if that were that many times, but there were 68 beats every minute, we can divide 720,200 by 68. And when we do that, we get 10,591.18 minutes. Notice I've labeled it. It's a good idea to make sure you label it. So this is how many minutes that took for the heart to beat that long. But to turn that into hours, remember there's 60 minutes every hour. And so the number of hours that are going to pass is less. So notice when we went from minutes to hours, we were multiplying by 60, but that's because it was a per minute and per hour. So remember the logic you need to think of when you're trying to divide or multiply, you're trying to decide, is here, I know it's going to beat more often in an hour than in a minute, so I need to multiply. But here, we're just talking simple time, and I know that there should be the number of hours that is the same as the number of minutes. That's going to be smaller, so I need to divide. So if I take 10,591.18 divided by 60, I'm going to get 176.52 hours. Again, just think about that, whether that makes sense or not. Does it make sense that it would be this many minutes? Does it make sense that this many minutes would be this many hours? If you're getting some huge number, that wouldn't make sense that that many minutes would be that many hours. But it does make sense that this many minutes would be 176.52 hours. Then to go to days, you divide by 24, and that's going to get you something like 7.35498,366 days. So here it said give the days in decimal form. So here, that's my answer in decimal form. But if you notice down here in C, they asked the same question, but they want the answer in days, hours, minutes, and seconds. And if you think about it, this right here, I don't have a good concept of what 7.35 days is, because we don't think of days in terms of decimal parts. We think of days in terms of the parts of the day that we break it down to are breaking it down to hours, minutes, and seconds. So we need to figure out this decimal part. That's the confusing part. We understand what 7 days are. But we need to take this decimal part and we need to say, well, there's also this 0.35 days going on, but how many hours is that? So we're going backwards. The plan now is to go backwards with the decimal parts and turn this back into hours, and then turn the decimal part of that back into minutes, and turn the decimal part of that back into seconds. So here, the decimal portion, if I take this many days, 0.35498, 366 days, and I multiply it times 24 to figure out hours, then I get 8 hours. And then there's also this 0.51960,784 part of the decimal. So I get 8 hours solidly, but I also get this 0.51960,784 hours. And again, I know that 0.5 hours is about 30 minutes, but if I want an accurate answer, I take this entire decimal and then I would multiply that by 60, because this is hours. This is still in hours. And so multiplying it by 60 reveals that that's 31 and then 0.1764706. So notice I'm separating. Here is the minutes, the whole minutes, and here's the decimal part of the minutes. And I'm separating the two so that I could turn this part into seconds. So I separated the 0.35498,366 days, and that became 8 hours. I separated this was hours, but that became 31 minutes. And this right here, this unit, the 0.176 is a unit of minutes, but I separated it from the whole number part, and I'm going to turn it into seconds by multiplying by 60 again. And that reveals, and now I can round to the nearest second. So that reveals, rounded to the nearest one, 11 seconds. So 7 days, 8 hours, 31 minutes, and 11 seconds.